All right, so get ready, because today we're going deep, deep into the world of pyramids.
Ooh,
Yeah,
pyramids.
but not the ones you're thinking of.
Not the Egyptian ones.
Nope, we're talking about the geometric kind. You know, those three-dimensional shapes?
Right, there's pyramids.
Exactly. But with a twist.
Mm.
We're going to unfold them, kind of like a blueprint.
A blueprint, so like we're gonna see what makes them tick.
Exactly. We're talking about nets.
Mm.
And to help us visualize this, we have this amazing interactive simulation.
Oh, a simulation. That sounds cool.
It is. It's from Open Educational Resources, Open Source Physics at Singapore. And get this, it uses WebGL, JavaScript, and HTML5.
Wow, all the fancy tech terms.
I know, right? But what it really means is you can access it on pretty much any device, even your phone.
So I could be exploring pyramids while on the go.
Absolutely. And the way it visually unfolds the pyramid, it's just incredible.
I can imagine. Much better than those flat diagrams in textbooks, right?
Oh yeah, this is like geometry in action. But before we get too ahead of ourselves, let's make sure we're all on the same page. What exactly is a pyramid, geometrically speaking?
The basics. Well, simply put, a pyramid is a 3D shape with a base.
Okay, a base, like a foundation.
Precisely. And that base can be a square, rectangle, you name it.
So different shapes for the base.
Yes. And that determines the type of pyramid. Square base, square pyramid, rectangle, rectangular pyramid.
Makes sense. So then what about the rest of it? The sides, I guess.
Ah, yes, the sides. They're all triangular faces, and they all meet at a point at the top. We call that the apex.
The apex.
That's
Got it. So we've got our base and our triangular faces meeting at the apex.
right. Now, back to that simulation you mentioned. How does it actually show this unfolding? I'm picturing a real pyramid crumbling, which sounds a bit chaotic.
Well, this simulation does it in a very controlled way. It's not like everything just collapses.
Okay, phew.
Each triangular face gracefully flattens out.
Like it's being ironed out.
Exactly. And you see this complete net all laid out. And the best part, it uses color coding.
Color coding, why is that helpful?
So you can easily see which face of the 3D pyramid matches up with which part of the 2D net.
Oh, I see. That would make it so much easier to understand. It's like connecting the dots, literally.
Exactly. And, you know, being able to visualize things like this, it's really important, not just for geometry.
Oh, you mean it has real-world applications?
Definitely.
Mhm.
Think about furniture assembly, packing a suitcase, even navigating a city.
You're right. Being able to picture how things fit together in space, that's crucial.
It is. Now let's talk about something a bit more practical, surface area calculations. How do nets help with that?
Ah, yes. Imagine trying to calculate the surface area of a pyramid just by looking at the 3D shape.
Trying to measure all those angles and sides sounds tricky.
It can be, but with a net, everything's laid out flat.
Oh, so it's easier to see each face and its dimensions.
Exactly. You calculate the area of each face and then just add them all up.
Like solving a puzzle. It suddenly becomes much simpler.
Right, and this has real-world applications too.
I bet. What kind of applications?
Well, think about packaging design. Companies use nets to figure out the most efficient way to package things.
Oh, that's clever.
Yeah.
Minimize material, maximize space.
Exactly. They're basically unfolding those boxes in their minds, just like we're doing with the pyramids.
It's amazing how something so seemingly simple has such a big impact.
It is, and it shows the power of visualizing and understanding shapes.
Absolutely. So we've talked about unfolding pyramids, spatial reasoning, and surface area. Are there any other cool things about nets that we should know?
Well, one thing that might surprise you is that a single 3D shape can actually have multiple nets.
Wait, really? So more than one way to unfold it?
Yes. Take a cube, for example. There are 11 different nets for a cube.
11. Wow, I wouldn't have guessed that many.
It's a fun challenge to try and picture all the different ways you can unfold a shape.
I'll have to give that a try. So it's not just about memorizing one right net.
Nope. It's about understanding the concept. And that's where these interactive tools shine.
They let you experiment, explore different possibilities.
Exactly. And make those aha moments happen.
It's learning by doing, not just by reading.
Absolutely. And speaking of learning, you mentioned some other resources for our listeners.
Yes, there's GeoGebra, which is great for creating and playing with geometric constructions.
Oh, GeoGebra, I've heard of that.
And the Annenberg Foundation has a fantastic interactive specifically about pyramids and their nets.
Those sound like amazing resources. We'll definitely have to check those out.
We'll dive into those more later, but for now, I think it's time to take a closer look at the tech behind this simulation. The way it uses WebGL, JavaScript, and HTML5 is truly impressive.
Yes. Let's peek behind the curtain and see how they all work together.
I agree. It's fascinating to see how technology can make learning so engaging. So let's take a short break and come back ready to unpack the tech behind this incredible tool.
Welcome back. You know, it really is amazing how technology is transforming learning, making complex things like pyramids and nets, well, much more accessible.
Yeah, it's like you said earlier, it brings geometry to life.
Exactly. And I'm really curious to learn more about how this simulation actually works. We were talking about WebGL, JavaScript, and HTML5.
Yeah, those three. What do they each do?
Okay, so think of it this way. WebGL is the artist of the group.
The artist.
Yeah, it's the one responsible for creating those smooth 3D graphics.
Oh, so it's making the pyramid look all realistic and three-dimensional on our screen.
Yes. And it's doing all the complex calculations behind the scenes to make that happen. It's translating that 3D world onto our flat 2D screens.
Wow, that's pretty impressive. So if WebGL is the artist, what about JavaScript? Where does that fit in?
Well, JavaScript is like the director. It brings those visuals to life, makes them interactive.
Interactive how?
Think about it. You can rotate the pyramid, zoom in and out, and even watch it unfold into its net.
Oh, right, and it's also smooth and seamless.
That's JavaScript at work. It controls all the actions, the animations, the way the simulation responds to your clicks.
So WebGL creates the visuals, JavaScript brings them to life. What about HTML5 then? Is it just watching from the sidelines?
Not at all. HTML5 is like the stage, the foundation for everything.
The stage.
Make sure the simulation can run in your web browser, no matter what device you're using.
So whether I'm on my phone, my laptop, it all just works.
Exactly. HTML5 makes it all possible.
That's amazing. You know, I'm sure some people might wonder, why should I care about the tech stuff?
That's a fair point.
Mm-hmm.
But I think understanding the technology helps us appreciate how powerful these tools can be.
It's like peeking behind the curtain, seeing how the magic happens.
Right. It's not just about geometry anymore. It's about realizing the potential of technology for learning. And not just geometry, really. Think about other fields.
Like what other fields are using these technologies?
Oh, all sorts. Architects use 3D modeling software to design buildings.
Oh, that makes sense. So they're kind of doing the same thing with buildings that we're doing with pyramids.
In a way, yes. And game developers are using these same technologies to create those immersive, realistic game worlds.
Wow, it's really everywhere.
It is. So by understanding how these tools work, we're actually gaining insights into a whole world of digital creation and innovation.
It's like learning a new language, the language of the digital world.
Exactly. And that's becoming more and more important these days.
Absolutely. So back to our simulation. How does it use this technology to make learning better? What are the advantages?
One of the biggest advantages is interactivity. You're not just passively watching or reading, you're actually doing something.
Right, like you can manipulate the pyramid, unfold it at your own pace.
Yes, it's hands-on learning. And that makes a huge difference in understanding.
I can imagine. And the visuals, too. Seeing the pyramid unfold in real time, that must help a lot.
Oh, absolutely. It connects the dots between the 3D shape and its 2D net.
Makes it all less abstract, more concrete.
Right. It's like bridging the gap between the world of geometry and the real world.
I see what you mean. So it's interactive, it's visual, it's really well designed.
It is. And it's a great example of how technology can make education more engaging, accessible, and effective. But it's not the only tool out there.
Right. We were talking to GeoGebra and the Annenberg Foundation Interactive as well.
Yes. And these are fantastic resources for taking your exploration even further.
Okay, so tell me more about GeoGebra first. What makes it so special?
Well, GeoGebra is this amazing dynamic mathematics software.
Dynamic. Does that mean it's like always changing?
In a way, yes. You can create geometric constructions and then manipulate them, change them around.
Oh, that sounds interesting. So I could build my own pyramid right there in the software.
Exactly. You can build it, resize it, unfold it into its net. You can really experiment.
So it's like taking those building blocks and building your own understanding.
That's a great way to put it. It's active learning at its best. You're challenged to think critically, solve problems, and discover things on your own.
I love that. It's not just about being told what to do. It's about figuring things out yourself.
Right. It's a perfect blend of structure and freedom. You have the tools and guidance, but you can also explore and experiment in your own way.
That sounds really engaging.
Yeah.
Now, what about the Annenberg Foundation Interactive? You mentioned that one too.
Yes. That one is specifically focused on pyramids and their nets.
So it's more targeted.
Exactly. It's a more guided approach, perfect for those who prefer a bit more structure.
That makes sense. What kind of things can you do with it?
Well, you can manipulate different types of pyramids, see how their nets change, calculate surface areas, all sorts of things.
It sounds really comprehensive.
It is, and it's a great way to really delve into the specifics of pyramids and nets, a nice complement to the simulation we were discussing earlier.
So we have JZebra for hands-on experimentation and the Annenberg Foundation Interactive for a more structured deep dive.
Exactly. It's all about finding what works best for you.
And having options is always a good thing. We've covered a lot of ground today. The tech behind the simulation, these amazing resources like GeoRShbibra and the Annenberg Foundation. But before we wrap things up completely, I think it's time to really challenge our listeners, give them something to ponder.
I like that. Leave them with a thought-provoking question.
Yes, something to spark their curiosity, keep those geometric gears turning even after the episode ends.
What kind of question are you thinking of?
So we've been unfolding pyramids, exploring nets, even diving into the tech that makes it all possible. But now I want to get practical, really practical.
Oh, even more practical.
Yeah, let's say you're an architect. You've designed this amazing building, all these cool pyramid shapes, right?
Sounds impressive.
But now you have to explain it to someone who, well, maybe they don't speak geometry.
Someone who's not a geometry whiz. That could be tricky.
It could be. So how would you use the concept of nets to help them visualize this building?
Ooh, that's a good one. It's like, how do you bridge that gap between the technical stuff and, well, just understanding how a building looks?
Exactly. It's like translating those blueprints into something everyone can grasp.
I think nets could be really helpful here. You could create a series of nets, like different sections of the building.
Oh, so like one net for each pyramid shape.
Yeah. And then you show how those 2D shapes actually come together to form the 3D structure.
It's like a step-by-step guide to building the whole thing in your mind.
Right. They could start with the base, add the triangular faces one by one.
I like that. Suddenly it's not this abstract concept anymore. It's something you can almost touch.
Exactly. It's all about that visualization. We humans, we're visual creatures.
We are, and this takes advantage of that, right? Using nets to make things clear no matter what your background is.
Absolutely. It's like a universal language, a visual one.
And you know, this isn't just limited to architecture. Think about product design, packaging, even fashion.
Oh, you're right. Anywhere you have complex shapes, nets can help. It's like a secret decoder ring for the world of design.
It is. It's a reminder that geometry isn't just some theoretical thing. It's all around us.
It's the shapes, the patterns, the way things fit together.
So, to all our listeners out there, I challenge you to look around and see the world through this new lens.
Unfold those objects in your mind. Break them down into their nets.
Think about how those shapes create the world we see. And maybe, just maybe, you'll come up with some amazing new applications for nets, things we haven't even thought of.
That's the beauty of it. There's always more to discover.
Absolutely. It's been a fantastic journey exploring pyramids and nets and the amazing technology that brings it all to life. We hope you've enjoyed it as much as we have.
We'll see you next time on The Deep Dive.